So we had two different colonies of bacteria. There was an initial placement of bacteria, 2 and 1 square centimeters of bacteria. And then every 10 minutes we checked the growth. Which of the following is a correct statement about the data above? They are not 100% covered when t equals 0. This part is true. Dish 1 is 10%, 20% dish 2. Dish 2 actually has 100% more. And this is backwards. Dish 1 is increasing at a higher rate, so B is the right answer. So this is our initial value, this is our growth factor, and then this is the part we put in the amount of hours. So if you put in 2 for t, that's 2 over 2, which is 1, and that 10,000 will have been multiplied by 2 to the first power, or 2. So 2 hours will double the initial value. The x-axis is t days after a star explodes. So they want to know how many masses, Earth masses of nickel-56 were there when it exploded. In other words, 0 days after. And that appears to be above 20,000, below 25,000. I'll pick 24,000. 4 is the initial value. 2 is the growth factor that we're doubling every time x goes up by 1. So this would be 4, 8, 16, 32, 64. We can use these coordinates to rule out these, which are exponential decay. We're looking at exponential growth. And C is growing too quickly. D is the right one. What is the best interpretation of the number 5,640? Well, this number over here is always the initial amount or the starting value. So since we are looking at t years after 2010, this is going to be the amount in 2010. We have a 2% rate annually, $200 in the account, that's the starting value. And to increase by 2%, we're going to put that as 1.02. You take 100 plus 2, and you divide that by 100. So this is for 2 years. What is the equation for 1 year? It's just this. So in this equation, we use the variable t for hours. If we want to convert that to minutes, we just take minutes divided by 60, because for every 60, that'll give us 1, which looks like this. So we start off with a value of 2. We triple every time we increase. So 0 is 2, 1 is 6, 2 is 18, 3 is 54, and so on and so forth. So just by looking for the 0 values, I can rule out a couple of these, well, one of these, 2 of these. And then if I look at the 1 value, this one's wrong. A is the only one that fits. We're increasing the total value of scholarships by 7% of the previous year. For the third year of the program, this was the amount. So how do you go back in time 3 years if we start with 750,000 and write that as an equation? Well, 1.07 gives us that 7% increase. And for the years, we're going to take the number of years minus 3, since we're going 3 years back. So that way, if we plug in 3, this will just be 750,000. And if we plug in 1 or 2, we will look back in time before this grew to 750,000 and find that value. This is D. In 2005, we had this many plants. They increased by 140%. So we take 100 plus 140 divided by 100, and that's how we get the growth factor of 2.4. So 10 initial value times growth factor to the power of the number of years. This expression gives the amount of money in dollars generated in a year by a $1,000 deposit in a bank account that has R percentage compounded monthly. Which of the following expressions shows how much additional money is generated at an interest rate of 5% than at an interest rate of 3%? So wherever R is, we're going to plug in a 5, and then we're going to plug in a 3, and we'll subtract the 2. So this has the 5. This part here has the 3. And we are subtracting the 2. That's why D is the right answer.